Hello, my name is Cecil, and today I'm going to walk you through an example of a future value of an ordinary annuity problem. In this example, on New Year's, you decide that at the end of the year, December 31st, you want to begin to make annual investments of $2,000 into your personal savings account annually. If the account is a 1.2% annual return, and you plan to retire in 30 years, how much money would you expect to have saved by the time you retire? The way that we figure out that we have a future value of an ordinary annuity versus any other type of problem starts with the recognition that we are making annual investments that are predetermined and constant. We're making the same $2,000 payment. This means that we aren't looking for the present value. If we were looking for the present value, we would be looking for the amount that we need to invest. And here we're looking for the future amount that we're going to have. So that tells us it's not a present value. We figure out whether or not it's an annuity due or an ordinary annuity based on the time in which we make our investment. Because we make the investment at the end of the year, that tells us that this is ordinary annuity and not annuity due. Annuity due would be done at the beginning of the year. If we had invested that day, then it would have been an annuity due problem, but because we make our first payment at the end of the year, that makes it an ordinary annuity. Finally, we know that this isn't a compounded interest because we're making continuous payments over the course of those 30 years instead of making a singular payment and then seeing how much money that singular payment accumulates over a given period of time. Following that, the equation for solving for the future value is equal to the payment per period multiplied by, in the numerator, 1 plus the rate to the power of the number of periods minus 1 all over r. We know that the amount that we invest each period is equal to $2,000. We know that the percentage that we get in return is equal to 1.2, or that the actual return in decimal is 0.012, and then we know that the number of periods is equal to 30 because we retire in 30 years. Our future value is going to be equal to 2,000 multiplied by, in the numerator, 1 plus 0.012 to the power of n, which we know is 30, subtracted by 1, all over r, which we know is 0.012, or it'll be equal to 2,000 multiplied by 1.012 to the power of 30 minus 1 all over 0.012, or our future value will be equal to 2,000 multiplied by, in the numerator, 1.43 minus 1 over 0.012, and that's equal to 2,000 multiplied by 35.855, and then a bunch of numbers after this. It's important not to actually round too early, because if you round too early, then you will get more inaccuracy in your numbers. The same goes here. I rounded here, but you wouldn't want to do that if you were doing this problem manually yourself. The future value would be equal to $71,710.21. So that's it for this one, and I will see you in the next one. Have a great day.